Hello everyone, welcome back to my channel The Learning Tree, and today we are going to learn about condensed and structural formula from the chapter carbon and its compounds. Okay, so here you will learn how to write a condensed formula and how to write a structural formula. So there are questions related to this topic, so I have made this video based on that. So we will be learning about these two topics and we will solve few questions based on that. Okay, so let's learn how to do it. Okay, so next is the types of formulas that are being used in chemical compounds, okay, or organic compounds. So two types of formula is there. One is the molecular formula, another is the structural formula. So when I say molecular formula, that means formula which represents actual number of atoms in a molecule. So how many number of atoms are present in a molecule, that will be shown using the molecular formula. For example, suppose water. So water will have 2 hydrogen and 1 oxygen. Okay, that's how we write the molecular formula of water as H2O. In sulfuric acid, 2 hydrogen, 1 sulfur and 4 oxygen. So the formula is H2SO4. So that is the molecular formula of H2SO4. That is the sulfuric acid formula. Okay, so that's how you write the molecular formula both for here in this case it is water is H2O and sulfuric acid is H2SO4. Now coming to the structural formula. Structure, you know what is the structure. Same way the formula which will show the connection between various atoms and groups in a molecule, that will give you your structural formula. So here you will see the bonding between the various atoms and the functional groups present in a molecule. For example, in H2SO4, if you take the same example, so what is the bond between hydrogen, sulfur and oxygen? That can be shown using the structural formula. Now if you see here, so this picture you will find it out. So see the 4 oxygen, they are bonded by double bonds, and you see the single bonds between oxygen and hydrogen along with the 2 oxygen atoms with sulfur are also single bonds. Okay, this is the in details connection or the bonds shown between the various atoms present in H2SO4. So 2 hydrogen, 1 sulfur and 4 oxygen. That's how you show a structural formula of a specific compound. Same way in organic compounds also we represent using structural formula or condensed formula. Okay, two formulas are there. One is condensed, another is structure. Condensed is the short form without any bonds, and structure formula is also known as dash formula, where you see show the bonds between the various atoms along with carbon. In this case here chlorine is also there. Okay, hydrogen, carbon, in between carbon atoms, then carbon and hydrogen. So all those bonds are shown in structural formula. Whereas in condensed formula you don't have to show any bonds, you straight away write the formula CH3CH, Cl, CH2, CH3. That's how you write condensed form. Or you can show it this way also, where chlorine is shown because it's a functional group, so that's why they have shown it separately. Or you can write it together as it is written on the right hand side. So without any showing any bonds, you have to write the condensed formula. So condensed formula is without bonds, structural formula is with the showing the bonds along with the atoms that are present there or the functional group present there. So in details, if you have to show the structure, then it comes under structural formula. Okay, and in short it will be the condensed formula. So let's do some questions based on that. So write the condensed formula for ethanol. That is the first question. So here you have to write the condensed formula. Ethanol. So ethanol is an alcohol family. It belongs to the alcohol family. Ethanol, OL means alcohol group is there. That is OH is the functional group present there. Okay, so you have to, how will you write the condensed formula? That means you have to not draw the structure, you have to write only the formula. So eth means 2 carbon, so CH3 CH2 OH. So this is the condensed formula for ethanol. And if you have so OL means OH, so that's why OH is there. And if I have to draw the structural formula, then this is how it goes. So O and H, so single bond, rest you'll fill up with hydrogen for both the carbon atoms. So that's how you write ethanol structural formula, and this is your condensed formula for ethanol. So see the question, what is being asked. If they are asking condensed, you write the condensed one. If you are writing the structure, then show the bondings and draw the structural formula. Okay, let's move to the next one. Here you have to draw the structural formula of methane. The structure you have to draw. So methane, it's an alkane, first member of alkane family. Okay. So the formula is what? CH4. Meth means single carbon. Okay. So AN is single bond. So all hydrogen. So one carbon. So rest all will be hydrogen atoms. So this is the structural formula of methane. Okay. So ANE means alkene. Always remember meth means one carbon. So this is the structural formula. I hope you understood. Next one, write the condensed formula of propane. So propane is another alkane. Okay, prop means 3 carbon. So let's write CH3, CH2, CH3. Alkane is there, so all are single bonds. So CH3. So this is the condensed formula of propane, 3 carbons. Okay. And you know the basic formula for alkane, how to identify an alkanes, how many hydrogen should be there for alkane. So it comes with the formula CnH twice n plus 2. Okay, so if you write in form C3H8, okay, so same formula can be written, molecular formula C3H8. So this is how you can find out whether your answer is correct or not. So put n value as 3. So hydrogen, how many will be there? 3 to the 6 plus 2, 8. So that means your answer is correct. Okay, that's how you check for an alkene. So C3, CH2, CH3. Next, you have to draw the structure formula of ethyne. Okay, ethyne is what? It's an alkyne family. YNE means alkyne. Alkyne means triple bond. You have to draw the structure. Okay, so if 2 carbon, eth means 2 carbon and YNE means triple bond. Okay, so you write C 2 carbons, then in between you put the triple bond because it's an alkyne. Okay, and remaining 1 hydrogen for each carbon atom you'll put it down. So this is the structural formula of ethyne. And if I have to write the condensed formula, so HC or CH. Okay, either way you can write. So CH or HCCH, both are correct. Okay, so that's the formula, and this is the structural formula of ethyne. And ethyne formula is CnH twice n minus 2. Okay, so you can check, if you put the carbon atom number of carbon n equal to 2, then you will have 2 into 2, 4 minus 2, 2. So 2 hydrogen will be there. So you see here 2 hydrogen. So that's how you know it. Okay. Next we have, give the structural formula for formaldehyde, that is methanol. Formaldehyde is the common name or generic name, and methanol is the IUPAC name. So you should know both, some of the compounds generic name also. Okay, so methanol. So methanol, Al means functional group present here is aldehyde. Okay, so that means CHO group is there, and meth means 1 carbon. Okay, and An means single bond. So how will you draw this structure? So here aldehyde group is there, that means CHO, right? So how will you draw? So C, then you put the double bond O along with that hydrogen, so that is CHO. Okay, and then you put the remaining one as hydrogen. So this is a CHO, and 1 hydrogen will be left, HCHO. So this is the structural formula, and the other one is the condensed formula. Okay, so this is formaldehyde or methanol. So you see the bonding there. So carbon will have double bond O along with H for the aldehyde group. Okay. Now we can draw that way also, this way also. We can put a double bond O on the right hand side, but this is more preferable. Now coming to the next question. Convert the following condensed formula into structural formula. CH3, CH2, COOH. Okay, so you have to write the into structural formula. So easy one. So already the bonds are given, but so directly write. So carboxylic group is there. First draw the 3 carbons. Then carboxylic group is there, COOH. So you'll have double bond O on one side and one side OH. Okay, and then you put remaining ones, you put the hydrogens there, up down, again on 3 hydrogen on the last carbon. So this is your 3 carbon, that is propanoic acid. Name will be propanoic acid, 3 carbons. So prop, single bond AN, and carboxylic group ends with oic acid. So propanoic acid. Okay, so that's how you identify the carboxylic group. Next one, CH3, CH2, OH. Now you see a functional group is OH, that means it is an alcohol family, so OL. So 3 carbons, and then put the OH, O single bond H, then the carbon will have the hydrogen, 1 up, 1 down, again 1 up, 1 down, and 3 more hydrogen for the last carbon. Okay, so this is 3 carbons, so prop, single bond, so AN, and alcohol is a OL, so propanol. Now this one is CH3CHO. CHO means aldehyde group is present. Okay, 2 carbon, so eth, so ethanol, single bond, and aldehyde is there, so it will end with AL, so ethanol. So CH3, C, and double bond O and H. This is CHO group, and the remaining ones with 3 hydrogen. That is your ethanol. Okay. I hope I am clear how to write the structural formula now. Now this is the another one. Write the condensed formula for the structural formula. Now here you see structural formula is given. You have to write the condensed formula. Easy one. You see if any functional group is there. So from there you can find it out. So here OH is the functional groups. Directly right away see this part CH3, then CH2, C, then put the hydrogen first, and then the functional group is in there. So OH. Okay. So this is ethanol. 2 carbons, so eth, single bond, so AN, and alcohol group is there, so OL, so ethanol. So this name of the structure or the form for this one is ethanol. Okay, so let's do some more. You have to write the structural formula for the following compound. Butane, so butane is an alkane. Okay, but means 4 carbon. So 4 carbon, single bond, ANA means single bond. So how will you do the, so you have to draw the structure for butane. So draw the 4 carbons, very easy. Now since it's an alkane, single bond, right, and now you nothing to worry, now directly no functional group, so directly put the hydrogens there, up, down, on the side. So hydrogen, here also hydrogen, up and down, on the side also. So this is the structure of butane. Next comes propene. So ENE. ENE means it's an alkene. So alkene has double bond. Yes or no? So propene. So you have to draw. Prop means 3 carbons. Okay. Then draw the bonds between the carbon atoms. Now ENE is there. So you can draw either on the first carbon or on the right or on the left. You put a double bond on any one side. Both are correct. Okay, so and then so this is a double bond is done. Now rest remaining is no functional group, just put the hydrogen. 2 bonds already on, so 2 hydrogen for this. Now for the middle carbon you see how many bonds will 3 bonds are there, so 1 hydrogen, and for the last carbon 3 hydrogen will be there. So be careful with the hydrogens when the bonds are there, double bond or triple bond is there. So always see total of 4 bonds should be there. So for middle carbon already 3 bonds between carbon, so 1 is left, so 1 hydrogen. So this is the structure of propene or 1' propene, since the first carbon double bond is there. Next is ethanol. So alcohol group is there. Eth means 2, single bond, AN, and then you have OH group for alcohol group, and remaining ones you'll put the hydrogen. Okay, so here 1 and 1 hydrogen. So this is ethanol. Okay. Next one, the condensed formula of a compound is CH3, CH2, CH2, CHO. So here this is the compound condensed formula is given. Now you have to first write the structural formula. So draw the structure in details. So here you see aldehyde group, 3 carbons are there. So straight away draw the 3 carbons and then the aldehyde group. So CHO, so C double bond O and H. Okay, and then remaining ones we'll put it as hydrogen. 1 up, 1 down, and then the remaining 3 for the last carbon. Okay, so this is the structural formula for this compound. Now second question here is identify the functional group. So as I've said, there is an aldehyde group. CHO is an aldehyde group. So the functional group present here is aldehyde. Okay, then also we have to write the IUPAC name of this compound. So how will you write the IUPAC name? Now see here 4 carbons are there. So but, right, and then you have alcohol group and single bond. So AN, butane, and then aldehyde group. So aldehyde group ends with AL, so butanol. So that's the IUPAC name of this compound, or you can also write 1-butanol. Both are correct. 1 dash because in the first position itself its CHO group is there, so that's why we put the position. So number 1-butanol, or only butanol also if you write, it is correct. So these are the 3 questions for that. Now last one, convert the following into structural formula. CH3, CO, CH3. Now you see the functional group what is present there. So in between if you see CO, okay, so that means it's a ketone. So for ketone you have to draw the structural formula. So ketone is C double bond O, right? We put ketone for, as on the top you write double bond O for the carbon, and remaining ones you'll put the carbons there. Okay, so structure you have to draw. So just directly draw the 3 carbons. Then for ketone you have double bond O, so in between you'll put the O. Okay, this is a ketone group. Okay, and then remaining ones will put the hydrogen. So 3 hydrogens for the right one carbon, and also another 3 hydrogen for the left carbon. So that's the structural formula for this compound. Now when you are drawing a ketone, you will always find ketone in between the carbon chain. You cannot find the ketone group at the end of the carbon chain. That is the terminal carbon, the right or the left, last carbon on the right or last carbon on the left. The ketone group you will never find. Ketone group is somewhere in between the first and the last carbon chain. Okay, so that's how you identify ketone. Ketone can never be at the terminal end. Always it will be in between the carbon chain. Okay. So here this is the compound. So here 3 carbons are there. So prop, and then single bond AN, and ketone ends with ONE. So propanol. Okay. So prop and then single bond. So AN, and ketone ends with ONE. So propanol, or you can also write 1-propanol. Okay. Both are correct. You can write propanol or propane-1-on or 1-propanol. All 3 are correct. So you can write either of these 3. Okay, that's how you draw the structure of propanol. Okay, I hope these questions are now you are able to draw the structural formula as well as the condensed formula for the various organic compounds that we have studied. I hope it is clear for you all. Okay, practice more so that you will be able to learn. Okay, so same. So here the condensed formula, if you see ketone, you can write CH3, CO, CH3. That is also correct without the bonds if you write the condensed formula. Okay, so thank you everyone. Thanks for listening and watching the video. So keep learning, and if you like my videos, please do share, subscribe, and click on the notification bell so that any updates on any new videos you'll be able to know. And comment if you want me to make a specific on a specific topic you want me to make a video. Please let me know on the comment box. And enjoy learning, and I hope to see you soon again with another video. Okay, so thank you everyone.